taking two pieces of metal using heat, pressure, or electricity and bonding the two together. Welding's been around since probably the Bronze Age or anywhere before that, but welding was different back then. They used something called forge welding, which is, as you've seen the old pictures of anvil and a hammer. Usually they make swords or weaponry back then. Welding as we know today, though, didn't really come about until the 1800s. That was when the first arc welder was made. Then automatic welding wasn't really around until about 1918, 1914. And since then, welding's taken off, and welding can be used for pretty much anything, like pipe, cars. That's not plumbing, but that's brazing. Music, brazing, and just general fabrication. And before welding, we used something called rivets. We still use rivets today, like on beams, but rivets are really weak compared to welding. It was expensive, cost a lot to make, and just took too much time to do structurally. So when welding was invented, really cut time and work in half and put rivets to shame. We still use rivets, like military still uses rivets. For some reason, I don't know why, but welding's better. Now, today's welding is usually produced by electricity. So, what is electricity? By definition, it's a physical phenomenon associated with stationary or moving electrons and protons. And what does that mean? No one really knows why electricity happens. It just does. Electricity powers anything from your cars to city lights, dryers, or water. Now, the two main parts of electricity that associate with welding are DC and AC currents. DC, which means direct current, it's basically like what your car battery runs off of. Car battery has a positive and negative. Current just runs from the positive back to the negative. That's shown there. Well, that's alternating current. Alternating current does the same thing, except it alternates back and forth from positive to negative, negative to positive. An example of AC current would be your wall outlets. They produce AC current. And power companies send AC current to your wall outlets because AC current cycles about 60 cycles per second, which they find that energy transmits further on AC than it does DC. Now, when you plug your welder into a wall or hook it up to your box, what happens is welders have transformers just as light poles have transformers. They transform high voltage and low amperage current to a low voltage and high amperage current, which is a primary source for welders. Welding in itself, like you see with the blue or white arc, what's happening there is a form of ionic bonding. There's a couple forms of bonding, but ionic bonding is anything with metal. Any elements in the periodic table of metal. And the temperature usually ranges from around 6,000 to 8,000 degrees. Something you would never want to put your finger into. And what makes welding more suitable and better than rivets is the fact that the bonding occurs at a molecular level, unlike rivets, which really no molecular bonding there. And in return, makes the overall strength a lot higher than rivets would. That's hard to see, but that's the stick welding basically stick welding uses a clamp and a stick about this long, and it sends current through the end of the stick, and once you touch the base metal it'll arc, and that's when the welding happens. And usually the sticks are covered in a flux, which help the weld prevent from oxidizing from the outside air. These are different weave patterns you can do. There's a Z, it's like a little U, little E's. Weave patterns not really matter too much. Usually the only time that usually matters is just depending on the work you're doing. Some people say doing little U's are better than doing zigzags on vertical. Overhead's usually a step pattern, which isn't shown there, but just different weave patterns you can do with the electrode. And those are some pictures of different welding processes. You got TIG, there's an oxy-fuel cutting, there's a MIG welder, there's a stick welder, there's a clamp with a little electrode. TIG is primarily used for really delicate materials like aluminum, that's aluminum pipe or stainless pipe. They use it a lot in automotive and food industries. You usually see these three in an industrial environment, usually in a warehouse. Then the welds aren't as clean looking as TIG, but usually these three are a lot hotter, usually do more. And for career wise, of course, you can actually be a welder, or if you don't want to be that for the rest of your life, you can always move up to be an engineer. Engineers usually design stuff like this, like pipes or oil pipelines, or design welders. You can be in sales, you can be an operator or an inspector or shop owner. And welding does require a lot of hand-eye coordination, but it's also a skill just like mechanics and machinists